Hello everyone, welcome to the class. Today let's talk about a little bit more about our file I/O stuff. So let's talk about the offset. So what's an offset? So before we talk about offset, because every resource is controlled by the kernel, so the only way we can talk to kernel, we can try to access to this resource is by using our system code. So that's a very fantastic system code called open, which can be used to open any device file because every device is packaged as a file. So you can open any files by using it to access to this device. For example, your network, for example, is I/O. Okay, but we covered the opens, close, and write and read. Let's talk about what's offset. Okay, so this is an example. When we open a file, we write something into the file. For example, we write ABC into a file. We got ABC inside the file, and right now we want to write another file, another string for DEF. We try to write another byte into this. So what this will be? If the write file, this file is just like no any other information to support, you should write DEF here, right? Because the write just like a start from the beginning, at the beginning of the file, try to write something. But this is not true because it's remember what you have before and try to write the new string after it. So actually, this second write system code will write a new sentence after ABC. Why? Why? Because there's an offset setting this information stored in your open file table, which we will cover will be covered in the next class. Okay, so let's talk about the offset. So because they remember the offset. So after you say ABC, they remember there's an offset here, like 2. The next time when you use another write FDDF, it will start from this offset, try to write three more bytes into it. So in this case, of course, it's update this offset after this write stuff. Read is the same. So this is called offset because every time you do something for this file descriptor, it try to remember the information. Where's your operation? Where does your operation do? Okay, so this is the concept. Actually, there's a very small piece stuff, another system code called lseek. lseek is trying to shift this information. For example, I open a file, I say happy. So when I open a file, my offset will be 0. If I want to read something, I want to skip HA. I want to just like read from PPY. I can say lseek, give some like a setting. Of course, we need to say this is what's the file descriptor. Give some setting mode. We can say, okay, I want to move it's 2. I want to move 2 bytes. I want to move 2 bytes. Shift it to here. So offset will become to P. Offset will become to P. Not 0 anymore. Okay? Because you shift to 2, you try to shift to 2. So lseek gives us a way to make the update of this shifting, the offset. And if we make this offset, it can give us a lot of convenience to do some stuff if we want to skip the string or we want to skip a couple bytes, or even we found some some problem might happen, we want to go back to check what happened before, we can use lseek to check it. Okay, so how to use lseek? There's a different mode to use lseek. Just let me show you some example. First one, if we have lseek, for example, 9, okay, so this is a read file. So after we open file, we call the read file, and this read file will change the offset by try to read happy because read 5 bytes. So each character is 1 byte. It's read happy here. Remember, this is nothing. Don't put /0 here. No /0. No. We read 5 bytes means we read by 5 bytes. We don't read 5 bytes plus /0. It's not the library function. It's not read string. It's just read the pure data. So we read H, A, P, P, Y. That's it. Don't put /0 here. Don't. Next time when we read, we will continue to read to put the character or to put the byte into here. So this is the idea. Okay. So okay, but let's go back to the offset. Let's go back to the offset after we do this read stuff because we read 5 bytes. So the offset will be changed to 5. Okay. So right now, if we say lseek, FDIN is the file descriptor 967. What it will be? 67 means I want to compute the offset by using the initial point, which is 0. Okay, so the 9, when we say 9 here, because we start from the 0, if we provide this mode, 6 set. If we provide this mode, we use this mode means we want to start to count the offset from 0. So 0 plus 9 equal to 9. So in the end, the offset will change to 9, and the offset will be point to this one here. Okay, because you reset the offset, how many bytes you want from the start. There's another mode, like a seek current. Seek current is different to seek set. Seek set, we start from the beginning. Seek current means I want to start from here. So if I want to start here, it will use the offset 5 plus 9 equal to 14 and direct your offset to 14, which is 6, 7, 8, 9, 10, 11, 12, 13, 14. It will be here. Okay, so you got the idea. Okay, so of course you can use -3 as a success. So it will be -5 plus -3, which is 2. So it's go back to point 2 here. This is the offset. Okay, so if you understand this offset, the offset can give you a lot of convenience. Okay, so this is a short lecture. We just want to show you there's a convenient like a system code called lseek can help you to like shift this offset. And of course, the concept of offset is so important. Next class, we will talk about how your kernel actually manage this offset. It's not, this information is not stored in your process. It's stored outside of your process. And how your kernel manage it, we will talk it in next class, next video. Okay, so I hope you enjoy this lecture, enjoy this video. See you next time. Offset is awesome.